We will discuss about the safety assessment of the bio-based materials. That means our group is involved in safety. That means, and I will debunk, that means some of ideas that because it's bio-based, it should be safer. They are just materials, and has any kind of materials, bio-based or not, they need to be evaluated. Safety is nothing related with biology. That means that's really something important. Please, you will see in the questions that means that we try to push a little the reflection about that. First, the bio-based materials, there is a lot of people spend a lot of time to define what bio-based materials are. You have a definition from the European that is standard agency. CEN is, I don't know if it is exactly standard agency, but their role is to develop standards. And they did, and part of it, and Sandra, we are part of this one, if you remember, for bio-based materials. That means they spend several years to define what they are. And the point is, do we have a specific regulation for something bio-based? And I don't want to go back to the previous presentation. That's really what you will find a summary with the help of ChatGPT to have nice pictures of what they are. That means one of the main definitions that you can remember, they are just bio-based means they are derived from renewable biological resources such as a plant, animals, and microorganisms. But this plant of animals even could kill you. And something also you have to remember is that means to make these modules, you use also chemistry. That means, and also if you think about wood, timber, paper, yes, that's the first chemical industry that has been created in the 19th century. That means it's not because it's really natural that we don't play with the chemistry. That means, and bio-based materials, that means they can be, you can have a small molecules, you build them as a platform, you combine the blocks, then you bring a second chemistry, you have intermediate, and you have the final products. Because you formulated them, you cross-link them, then you can do a lot of things. That means a priori, we have to consider that they contain also a lot of substances. What they are, that means they can be bioplastics, the example of PLA. That means they could be, that means, just to check if I miss one thing. Yes, you have that the most common bioplastics that means are currently on the market. You can read that they could be plant-based. And I give here an example because we will discuss this a little later. It's a bamboo fiber lunch box, which is really popular, and we are close to the lunch time. I mean, you can think that bamboo is that could be fantastic. That means it's natural for sure. It's biodegradable. Then we can discuss a little. And why not? That could be safe. Don't forget, these materials can be really physically or chemically modified. That means why not to add nanoparticles? That means we have specific regulation for the use of nanoparticles. That means then question, are bio-based materials safe or even safer than petrol-sourced material, for example? That means, the point, that means you have many times allegation, such as bamboo versus plastics. It's not bad for the environment. I don't fight that. The question is safety. That's what we will discuss. And here I give you some examples. That means you have examples. That means we need to rely on facts, not about opinions. And I took something from the Dutch Enforcement Laboratory. That means it's a study they did in 2022. If I remember, they check pepper, wood, bamboo, bagasse, palm leaves, banana leaves, cocoa shell, reed, wheat, bioplastics. That means, and they are clear. 10 of the 28 samples contain active substances. That means they found some PFAS. That means the conclusion they reach. Bio-based materials may contain substances that give rise to Earth's concern, including plant protection products. You can have a pesticide in particular, because to produce this plant, you may use also chemicals. That means you can find that they were surprised, and that means of fluorinated compounds, and they found also plasticizers. And that means, and one of the problems is really they analyze the materials. They did not have the time, and the supplier did not do any migration. to see whether these chemicals could be transferred to the food or food simulants. They didn't have this information. And I said that these data were required for quantitative risk assessment. And they stated clearly, because they stated, that means bioplastics is clear. That's covered just by the regulation of plastics, bio or not bio, not just plastics. And that means that will have consequences. That means the substances that have been positively listed. That's to give you, that means an overview of what you can find in bio-based materials. You can have different kind of contaminants. That means you can have residue, you can have sometimes toxins, nanomaterials, endocrine active chemicals, heavy metals, persistent organic pollutants, process contaminants, genetically modified GMO organisms. That means, and you have to check something that is very often forgotten for allergenicity. Imagine if you use something from proteins and you modify these proteins, and if there is a risk that something is transferred, that need to be covered. That means one intermediate conclusion, bio-based materials are not less chemical than others. They just contain chemicals, and we have to manage them as such. That means we need to apply safety assessment. And you will have some kind of guidance, something I try to be a less European-centric. Well, what I said this morning, we are a little European-centric. You have the guidelines to evaluate bio-based or any kind of materials in Europe. That's the EFSA guideline. You have the FDA guidance that include to have data on chemical composition, migration testing, toxicological evaluation, and to have an estimate of the exposure if we were generalizing this kind of materials. That's the beginning of the approach. Then we will go into details and we will pick some examples. That means you have things in Europe. That means you have things in the US. You have here the framework that can be used for the two block. That means in Europe, it's quite simple. That means everything, bio-based or not, should not endanger human health to modify the composition of food. That's something that we have in the General Regulation 1935, 2004. That's clearly stated. We have specific regulation if they are plastics. If they are plastics, that means all the substances that are used need to be positively listed, including monomer. You don't have your monomer, you don't have your additives, even if it is bio-based, that can be used. This is clear. We will take the example of bamboo and you will say it. And for some of these substances, you may have restrictions. I mean, you need to check that these substances do not migrate above the limit of exposure accepted by the bloc, the country. You have the same Europe and US, that's some very similar principles. Something which is more complicated is paper, board, wood, bamboo. That's super funny, that method is not so strictly regulated. Then for Europe, we have to rely at the top level of the recommendation of the Council of Europe. Currently it's 47 countries. I mean, this is larger than the EU, you will have a map. And for wood and bamboo, we may have other consideration. We have to rely on EFSA. Then that is quite similar in the US. In the US, they don't regulate materials, they regulate essentially for contact substances. That means the capacity of substances to be transferred, whatever the origin of these substances. And they enforce also in the US, in particular for paper and board, they emphasize about good manufacturing practices. That means here you have bio-based, that means you have standard for that means renewability, biodegradability. That means, and we are discussing for application in food packaging, and I will take one example. It's something we discuss, cellophane or cellulose derivative, which is really old bio-based material, and they are strictly regulated in both cases. In Europe, you have a specific directive for cellophane, and you have something specific in the US. And you will see that it's really similar. They try to protect the consumer for the same concern. Because it's not anymore cellulose, it's really chemically modified cellulose. I mean, you induce a reaction, you have residue, you have products, and you have to check that the substances that means are not transferred into large amounts. And something that in Europe, that means because we categorize, that means the materials, we don't have a category bio-based. We have 17 categories, but no specific category for bio-based. But you have 11 groups that could be categorized as bio-based: plastic, regenerated cellulose, some elastomers, paper and cardboard, wood, textile, active materials, that could be also bio-based, some adhesives, cork, some printing inks in some cases, and some varnishes and coatings that could be also bio-based. Not necessarily bio-based, but you have nothing specifically bio-based. That's really a strong message that we have. That means a way to understand a little the way we manage in the EU. Bio-based is not a good entry. We could separate, if you want, organic, fibrous, and inorganic. That's some category that we could do. That's what we apply mainly. That means for all materials, we have two main regulations. We have one regulation that says you should not endanger human health, simple. And second is really you need to have good manufacturing practices. They means general framework regulation. Every materials among the 17, including all bio-based, should comply with this. And for good manufacturing practices, that means that's controlled by the industry itself. That means they need to put that in place. That's the one specific, that means if we go to the details for plastics, because you will have different branch, we have no time to enter into the details. But what I want to give you is really an example. This example is a simple one. You may recognize this. It's some plastics materials containing bamboo fibers. That could be used as a cup. Something we used to have in our research group, we bought this kind of cup from China. They got inside a small label saying that is really compliant. They are illegal. That's the same of this kind of plate. They are made reinforced with bamboo. They are illegal. And the point of view, that means the argument of that, plastic materials intended for food contact must be manufactured with substances authorized under Regulation 10/2011 for all plastics. We have 900 substances listed. That means bamboo is not. And what the European Commission say, because it's the text of the European Commission I took, that means with bamboo and other plant additives, they are not in the union list. That means they should not being sold. They are illegal. And these products are often falsely claimed to be natural, eco-friendly, compostable, that mislead the consumer. And even the term organic can be misleading. That's what the EU is saying. But this is legal if it's made uniquely with bamboo, because it's not plastics. You have the right to tell me that the plastic is it's the law. I don't overinterpret. It's something we debated a lot in our group. That means when the bamboo crisis occurred, because we got initially different opinion. None is really clear, the point of view of the EU. That means, and you have more than 46 different product recall or block at the European border. That is regarding product in bamboo. That is something that is really well documented. But I think it's a good example. Something also, to be honest, that means the current regulation in Europe, we have different workshops to identify the limits of our regulation. And it's clear, it was recognized during one of these workshops, the current rules do not encourage development of safer and more sustainable alternatives. We agree with that. We need to change the regulation for that. You have you have 6 pillars that are used to draft the new regulation of all food contact materials within the EU. We are still at the stage of drafting. This is not in the final version. It's debated a lot between member states. But I want to highlight there is one pillar is supporting more sustainable alternatives and to give more priority or more sustainable use of food contact materials. And we need to have something which is coherent with everything. It's not an easy task. but that's something which is scheduled, and that will happen. That we give a chance to have a safe use of bio-based when they are good for the environment. If I take the example, that means because you have things that are managed not directly by the European Commission, but outside at international level, and you have the European Committee for Food Contact Materials and Articles, and also they have in their agenda, that means they need to, what they don't make legislation because they don't have this mandate. They made recommendation. And they will propose different, they're quite binding, but they are not legislation. That's not the exact term. They provide a technical guidance, and you will have several technical guidance that will happen in the near future. You have the deadline here from 24 up to 27, and they will manage, that means they will propose the things also for bio-based materials. And now we will discuss another specific materials is paper and cardboard. It's not something new, but at the time that people would like to have more environmental friendly solution, why not to shift to paper and board? If you shift paper and board, that's managed with the two guides, strictly paper and board from the European Council, and they include paper and board are very often printed, and is attached also the part of printing inks. And you can think also about adhesives, which is not managed by them. For paper and board at European level, you have a positive list of substances that you can use to modify paper and board. That's really clear, the kind of substances that's in the European regulation. If you take the German one, that's the same. You have really a long list of substances. It's more extended in the German one. If you go to the French one, you have it. That's the same again. We are not fully synchronized. You can see the point of view may differ, but again, it's going to the same direction in both cases. And I want to highlight some specific point of view of the French regulation, because it's something we contributed to. You have something specific. We say that we need to consider the risk of mass transfer. That means for sure for dry, that means fat product, but also for aqueous one. In the law, we state clearly any kind of food. It's not limited to solid, it's not limited to fatty products. It's for all products, including aqueous ones. You have to think about beverages, the cup that's covered. We introduce also the concept of mass transfer without contact. That open also, you need to consider the risk of transfer from the over packaging. That's due to the crisis that we had with mineral oil, because the over packaging usually is made with recycled fibers. And the layer in contact with food is less and less made with recycled fibers, because bio-based, why not? Why not to recycle bio-based? Why to consider that it should be biodegradable? According to your French law, it is encouraged to recycle any kind of materials, biodegradable or not. Why to give the energy back to microorganisms? If we spend energy, why not to keep this energy, the energy that is stored inside the matter? That means it's something specific that we have in the French regulation, and then we shift rapidly to some recycled paper and board. I took some results before taking the result of Lucas. Lucas in the back, raise your hand. Yes, that's the guy behind you. You can discuss with him if you want. He's doing his thesis. But it's, okay, it's small, but if you zoom on it, you will see with naked eyes, it's difficult to evaluate whether a paper and board is recycled or not. Invisible light is difficult. If you use UV light, ultraviolet, you can see small points inside on the fibers. You have some part of the fibers that absorb ultraviolet that induce some fluorescence. And here, that's a product that is we took on the French supermarket. We know that is made with recycled materials. And you can see, that means in the packaging, it's packaging of popcorn, remove the brand, you can detect a small spot inside. And here, we use a laser, which is not UV, which has is really dark blue. And you can see spots that are induced by fluorescent that we see, that means in the fibers. That means you have some distribution of the chemicals. Here you have what we did. You have a cartography of the spot inside the fibers. That means it's not all the fibers that contain something that interact with light. Some of the fibers contain something. Since the fibers are entangled to create a network in the denser materials during the recycling process, they mix everything. And don't forget, the paper and board industry do not decontaminate their materials when they recycle them. They try to control a little the color, but they don't decontaminate them. You will see in my presentation tomorrow that for plastics, we decontaminate them it's mandatory if we recycle them. But for cellulosic materials, and even we can do profile across the thickness of materials. So we're using Raman spectroscopy, and we can identify specifically the fibers that contain aromatic compound. They are not part of the cellulose, not at all. But these molecules are completely artificial. And we can identify, that means that's the list of the substances in the European regulation, in the French regulation, we have 50 substances that need to be monitored and need to be evaluated. Something we did in different kind of products. Something I want to share with you among the 50 products, that means on the commercial products, when you find a dot, that is molecules, we found them in recycled. Paper and board, and recycled or not. That means even when they are virgin, we identify a lot of them. They are present. That means question, can bio-based materials safely use, reuse, and recycled? Because I need to reach a conclusion. And before that, I just want to share with you that if the chemicals are present in your materials, there is a risk of mass transfer. This risk of mass transfer can occur even if you don't have direct contact, even if you have a plastic layer between the food and the materials, or even if you have your materials, air, plastic, air, and food, you can have even a mass transfer. That means here, that's data of the group of Conigrub. Here you have a pasta. That's the matter that is lost by the box. That's the matter that is accumulated in the food. The same in the muesli. That means something is lost by one and is recovered by the other. That means that's a proof that you have some causality of the substances. Something we did, and I was part of the thesis of Mai quite a long time ago. Raise your hand, Mai, if you want to discuss with her. She's behind. That means we did this kind of experiment. In this case, you have a plastics, B-oriented polypropylene. You have here the kinetics for different class of substances, different temperature, 20, 40, 60. 60 is close when you put something in the oven, or you leave it, or you leave it in your, that means in your car in summer. And here you have an alkane, here you have phthalate, here you have photoinitiators, here you have aromatic mineral oil, anthracene and naphthalene. And in all cases, you have transfer. And we have two types of kinetics that are super fast, the others that are controlled by permeation. And we were able even to do, that means some kind of control lines. That means how much time you need to wait at a given temperature. That is, if you set 30 days at 60 degrees, for example, during a long transport, I don't know, by ship across the Africa today, what is the amount of mass transfer that can be, that you can reach is 30%. And here, that's the opposite. We take a migration rate of 1% at room temperature, how much time that we need to wait. If you have dry food, it's 200 days. That's quite likely. That means all the substances, if they exist, if they are contaminants and they are harmful, they can be transferred. That means the hazard may be there, then you need to manage the risk. You need to be sure that the exposure is acceptable. That means it's an example of bio-based materials. That means some takeaways, because it's time to go to have a lunch. If it is plastics, you have to follow rules of plastics that rely on low toxicity, low migration principles. If they are non-plastics, that may depend on specific regulation. For paper and board, we have something a little similar. And that depends on the country. I insist, that means this bio-based material, usually we print on it And we got a lot of issues in the past with printing ink. It's still not so well managed either in Europe or US or even China. We have to be careful. We are still have an open crisis, not completely resolved on mineral oil. It's something that we discovered in 2011 or 2009. That's something that was underestimated by the industry before. And I give you some pictures, in particular for eggs. There are things that I like. That means that look, and that means don't expect that everything is resolved. That's what I can tell you. And I think it's my last, yes, we removed the last slide. We have the thank you that has been removed. That's my last slide. I don't know if you have questions. If you don't have your urgent question, please put the question in the chat. We will try to ensure. I don't know, Gemma, if you have a question in the chat. And for those that are attending today in person, we can continue the discussion during the lunch, perhaps it's better. Thank you very much.